Position is the exact or related location of a body, and motion is a change in position. And when the motion of the body is steadily or in a steady manner, then we refer it as uniform motion. So, and if the body have no uniform motion or its velocity is changing, either increasing or decreasing, so we consider the body is accelerating. Thanks for student Halelia for member of our team for her presentation. And now I will proceed to the next topic, which is about acceleration. So, considered or when compared to the velocity vector or displacement or position vector, this acceleration quantity may seem like a very scary or a fire-breathing dragon of motion variables, but that's because when considering a body accelerating, its effect is very magnificent and can be easily noticed. So what's an acceleration? Acceleration is a quantity telling us the number of meters per second by which a body changes its velocity within a specific time. So acceleration is simply a change in velocity of a body within a specific time interval. So here, as we know, when we say time, we mean by elapsed time. Since there's a fact that time never stops marching, so when calculating, we just consider a specific interval or an exact instant of which the body just experiences a change or a slight advancement in its encountering velocity. So acceleration can be violent, and many people can just get scared of, but it's because it forces us to take notice or to observe it. So an object may have zero acceleration and a non-zero velocity, and that's while a body is under uniform motion or experiencing uniform motion. So so what's an effect of force? Or force is one of the vectors. So force is required or necessary for a body to either change its velocity by increasing or decreasing or change its direction. So we can say that acceleration is one of the effects of force, so that a body is said to be accelerating either if changes its speed up or slow down or change its direction. So we want to compare here a rectilinear motion and a circular motion. So let's say here is body A. Similarly, here is body A. So if a body is having a motion or is moving in a rectilinear path or in a straight path, then we can consider the body accelerating if it's speed up or slow down or change its direction. But when we consider this circular path or during circular motion, or if body is moving in a circular path, then whether there is an increase in its velocity or not, or whether its velocity is constant or not, it's considered to be accelerating since there is a continuous change in its acceleration every instant of time. And the other thing in acceleration is the direction or the direction of acceleration. So the direction of acceleration simply can be determined by the direction of the change in velocity, since we have said previously that acceleration is a quantity describing the change in velocity of a body. So we say that the direction is determined in terms of the change in velocity encountered, but that doesn't necessarily mean that acceleration always poses the same direction as the motion of the body or as the direction of motion of the body. The second thing to mention is about Newton's second law of motion. Obviously, as we know, this law of motion is among the three well-known and famous laws of Newton in physics, and it's also called as the universal law. And what's the need behind, or the essence behind mentioning this law of Newton is because acceleration can be also determined or expressed in terms of the amount of matter contained in the body or the body's mass and the force acting upon it, besides describing it in terms of the body's velocity or position. So this law states that the acceleration of the body is directly proportional to the force acting upon it, but inversely to the body's mass. So this means this can be mathematically expressed as acceleration equals force over mass. So here acceleration and force are directly proportional, whereas acceleration is inversely proportional to mass. So using this equation or using this relation between each of these quantities, we can simply tackle or calculate different problems and different equations related to this component or to this topic in physics. And the next thing is about types of acceleration. So there are different types of acceleration. The most commonly known type of acceleration are the positive and the negative acceleration. So we say of an acceleration it's positive when it has the same direction as the velocity of the object. And we say that the acceleration is negative when the velocity and acceleration of the body are running or they are along different paths or opposite direction.